Hi guys, this is the second video on predicting products. This one is on double replacement. So double replacement, in my opinion, is just a bit easier than single replacement because we don't have to worry about does this reaction actually happen. It's assumed to happen. So what we're going to do though is we're going to take bromine and we're going to switch it with the other anion, which is oxygen in this case. So we would then pair aluminum with oxygen and iron with bromine. Now, in order to write the formulas, we do have to take into account the charges. That's how we make our formulas. So aluminum is a +3 from the periodic table. Oxygen is -2. In order to cancel these out, you can use your circles or simply write the charges again. So -4, +6, and then -6. So it took 3 oxygens and 2 aluminums. And then I have to erase my charges because neutral atoms do not have a charge. They're neutral. All right, same thing for iron. Bromine is a -1. Iron's a tricky metal, so I have to go over here in order to find the charge of my tricky metal. Using my circles, like I've shown you before, we can know that iron is a +3. And so it takes 3 bromines to cancel out that +3. And then I erase my charges. Okay, so on this next reaction, we're just going to do the same thing. This one has a polyatomic, and again, this is why I had you guys memorize your polyatomics, so you could recognize that those stay together as a group. All right, so silver is now going to be matched up with chlorine. Silver's a +1, chlorine's a -1, so that's easy. And then zinc has to be a +2 because there's 2 chlorines, and nitrate is a -1, so it's going to take 2 nitrates to cancel out that zinc. And if you have any charges, you would erase them at this time. Okay? Okay, and so the next equation, we're going to exchange nitrogen and hydroxide. So we have sodium, which is a +1, matching up with hydroxide, which is a -1. And then rubidium, which is a +1, and nitrogen, which is a -3. So it's going to take 3 rubidiums to cancel out that nitrogen. Okay? When we're going from names to formulas, we just have a little bit more work to do. We always write the part with the charge, okay? And then we have to cancel the charges and put them together. So this is ammonium sulfide plus barium iodide. Okay, and now I'm going to switch my 2 anions in order to put ammonium together with iodine. We do not need that parenthesis. And barium, which is a +2, together with sulfur, which is a -2. Okay? So our full reaction there would be ammonium sulfide plus barium iodide would make ammonium iodide plus barium sulfide. So it's not yet balanced, but that is the full reaction. All right, remembering that the Roman numerals are the charge. So lead 2 fluoride. Fluorine is a -1 charge, so that's going to be PbF2. Silver's a positive 1, so Ag plus 1. Phosphate is a negative 3, so PO4. All right, and then we're going to switch fluorine and phosphate. So lead, which is a positive 2, I already know that. Let me zoom out here for you. Okay, so lead, which is a positive 2, is now going to be matched up with phosphate, which is a negative 3. So we would use our circles. And that would result in Pb3PO4 2. And then silver, which is a positive 1, being matched up with fluorine, which is a negative 1, so AgF. Okay? So that's how you predict products for a double replacement reaction.